There's a planet out there where the sky screams with winds 5 times faster than the speed of sound, where shards of glass tear through the atmosphere like bullets, where you wouldn't die from the heat or the cold or the lack of oxygen. You'd be shredded before you ever hit the ground. And that's just Tuesday in the Milky Way. For centuries, we gazed at the stars and wondered what kinds of worlds circled them. We imagined distant Earths, maybe bigger, maybe smaller, but fundamentally similar, safe harbors for life, governed by the same gentle physics that shaped our home. Then we actually looked. What we found defies imagination. Planets that shouldn't exist. Worlds that break every rule we thought we understood. A cosmic freak show of extremes that makes our solar system look like the universe's quiet suburb. Welcome to the carnival of the strange. Welcome to the Milky Way's most extreme exoplanets. Our journey begins with the impossible. Planets that orbit not one star, but 2. Kepler-16b was the first confirmed world of its kind. A gas giant locked in a gravitational dance around a binary star system, 400 light-years from Earth. To stand on this world, if you could, would be to witness twin sunsets, just like the iconic scene from a galaxy far, far away. But Kepler-16b isn't alone. NASA's Kepler mission has revealed dozens of these circumbinary planets, scattered throughout the galaxy like cosmic oddities. Some orbit their twin stars so closely that their years last mere weeks. Others drift in the freezing outer reaches, where both suns appear as nothing more than brilliant points of light against the eternal black. The physics shouldn't work. The gravitational chaos of 2 stars should tear these worlds apart, scattering their material across space. Yet somehow, they endure. Silent witnesses to forces we're only beginning to understand. These Tatooine worlds shatter our assumptions. They prove that planetary formation is far more resilient, far more creative than we ever imagined. Now imagine a different kind of nightmare. A planet with no star at all. Floating through the galactic void, these rogue worlds drift in absolute darkness and cold. Ejected from their birth systems by gravitational violence, they wander the space between stars, orphans of cosmic catastrophe. We can't see them directly. They emit no light, reflect no starlight. But we know they're out there. Gravitational microlensing, the warping of space-time itself, has revealed their presence. As a rogue planet passes between us and a distant star, its gravity bends the starlight, creating a brief, telltale flare. A ghost's fingerprint. Scientists now believe there may be billions of these nomads in the Milky Way, possibly outnumbering the stars themselves. Some of these worlds might harbor life, not on their frozen surfaces, but deep beneath, where radioactive decay and residual heat from formation could maintain liquid oceans in the crushing dark. Life without sunlight. Life sustained by the planet's own dying warmth. They drift through the cosmic night, silent and unseen. Free from any sun's gravity, but condemned to eternal twilight. If rogue planets represent the frozen edge of possibility, then hot Jupiters are their polar opposite. WASP-12b orbits so close to its star that its year lasts just 26 hours. The daylight side reaches temperatures exceeding 4,000 degrees Fahrenheit, hotter than some stars. The planet's atmosphere is literally being stripped away, feeding its host star like a cosmic vampire. But the horror deepens. On HD 189733b, another scorching world, astronomers have detected something extraordinary in its atmosphere. Silicate particles, glass, blown sideways by winds reaching 4,000 miles per hour. It rains glass on this world, sideways, in storms that never end. And then there's WASP-76b, where the temperature differential between day and night creates something even more surreal. The daytime side is so hot that iron vaporizes, rising into the atmosphere as metal clouds. As these clouds drift to the cooler night side, the iron condenses and falls. It rains molten iron at dusk. These aren't planets as we understand them. They're furnaces. Crucibles where the laws of chemistry and physics play out in the most extreme conditions imaginable. Each one is a laboratory of the impossible, teaching us that matter can exist in states we never predicted. Saturn's rings are magnificent, a cosmic crown spanning 200,000 miles. We grew up believing nothing could rival their beauty. Then we found J1407b. This gas giant, roughly 16 times the mass of Jupiter, possesses a ring system so vast it defies comprehension. The rings stretch over 37 million miles in diameter, 200 times larger than Saturn's. If we replaced Saturn with J1407b in our night sky, its rings would dominate the heavens. They would appear dozens of times larger than the full moon, arcing across the sky from horizon to horizon like a celestial bridge. The rings contain gaps, empty spaces carved by the gravity of undiscovered moons. At least one moon, possibly dozens, orbit within this system, shepherding the material into intricate patterns. Standing on J1407b's hypothetical moons would offer a view beyond imagination. Rings stretching into infinity above you, blocking out sections of the sky. Eclipses that last for weeks as massive ring sections pass between you and the sun. This is what happens when planetary formation goes into overdrive, when the disk of material that usually forms a few moons instead becomes a solar system within a solar system. GJ1214b presents a different kind of extreme. This super-Earth, 40 light-years away, is what scientists call an ocean world. But forget tropical paradise. We're talking about an ocean that covers the entire planet, hundreds of miles deep, crushing down onto a core of rock and exotic ices. The pressure at the ocean floor would be millions of times greater than anything on Earth. The water itself wouldn't be liquid as we know it. It would exist in bizarre high-pressure states called hot ice and superionic water, where oxygen crystallizes while hydrogen flows freely like a liquid metal. Above this alien ocean, a thick atmosphere of steam and hydrogen presses down, creating a greenhouse effect that keeps surface temperatures near 500 degrees. No islands, no continents, no escape from the endless, crushing deep. If life exists here, it would be nothing like anything we've encountered. Organisms adapted to eternal pressure, eternal heat, eternal ocean. Forms of chemistry we can barely imagine, operating in conditions that would instantly vaporize any Earth creature. GJ1214b reminds us that Earth-like is a dangerously narrow category. The universe creates worlds we never anticipated, and life, if it's out there, might be far stranger than our wildest dreams. PSRB 1620-26b holds a record that might never be broken. At 12.7 billion years old, this planet formed when the universe itself was barely a billion years old. It orbits a binary system consisting of a pulsar and a white dwarf, the corpses of stars that died long before Earth was born. This planet has witnessed the entire history of the cosmos. It existed before galaxies took their current shapes, before our sun ignited, before the molecular clouds that would become our solar system even formed. It's often called Methuselah, named after the biblical figure who lived for centuries, but even that doesn't capture the scale. This planet is older than nearly everything. The environment is hostile beyond measure. The pulsar bathes everything in lethal radiation, and the gravitational dance between the two stellar remnants creates tidal forces that would tear most worlds apart. Yet Methuselah survives. It's a time capsule from the universe's youth, carrying secrets about planetary formation in conditions radically different from today. It proves that planets aren't fragile, they're survivors. Witnesses to cosmic time that dwarfs human comprehension. We used to think we understood planets, rocky worlds close to the sun, gas giants farther out, everything in neat, predictable orbits. The universe laughed at our assumptions. From binary sunsets to glass rainstorms, from ring systems that dwarf anything we imagined to oceans deeper than worlds, the Milky Way has revealed itself as a cosmic carnival, a gallery of the strange, the extreme, the impossible made real. These aren't just distant curiosities, they're laboratories. Each one teaches us something fundamental about physics, chemistry, and the raw creative power of gravity and time. And we've only just begun to look. With next-generation telescopes coming online, we'll discover thousands more worlds, more extremes, more impossibilities. The carnival is just getting started. And, somewhere out there, orbiting a star we haven't noticed yet, might be the strangest world of all, one where someone is looking back at us, wondering if we're the impossible ones. The galaxy is vast. The galaxy is strange, and it's all waiting to be explored.